Given the polynomial f of x equals x to the fourth minus x squared minus 2, find the complete factorization. When I say complete, I mean all the way down till all of the factors inside of the parenthesis are first degree. They don't have anything higher than x to the first power. Find that complete factorization. And then part B, find all the complex zeros. That means all the real and all the imaginary zeros. And don't forget, the real zeros consist of both rational and irrational zeros. Okay, let's do part A. Find the complete factorization. Let's see, we've got f of x equals our given x to the fourth minus x squared minus 2, and we can factor that by guessing x squared minus 2 times x squared plus 1. Let's see, now to find the complete factorization, we have to figure out what roots go in there, because you see, as it stands now, each of those factors in parentheses are not first degree. Those are second degree factors. They need to be broken down further. And if it's hard for you to see how it's done, well, just set the darn thing equal to 0 and solve for x. That will be the value you're subtracting from x to get your linear factors. Let me show you what I mean. Let's take the x squared minus 2. That's the first factor, x squared minus 2, and set it equal to 0 and find the roots. X squared minus 2 equals 0. That means that x squared is equal to 2. I move the 2 over. So x is equal to plus or minus the square root of 2. Yes, there it is. Our roots are positive root 2 and negative root 2. So we can factor this down to linear factors, x minus the root times x minus the other root. Those are our first degree factors. Now you'll notice it's x minus the square root of 2 times x minus the negative square root of 2. That double negative made it look like a positive, which indeed it is. Okay, so let's go to the other factor, the second degree factor x squared plus 1, and let's figure out what that root is. Let's set it equal to 0 and solve for x. X squared plus 1 equals 0. Okay, find its roots. All right, we're going to move the positive 1 to the other side by subtracting it, and we'll get x squared equals negative 1. And then we're going to take plus or minus the square root of both sides to get x equals plus or minus the square root of negative 1. So x is equal to plus or minus I. Thus, the factorization in linear form of x squared plus 1 is x plus I times x minus I. Okay, so let's put all this information together and draw our conclusion. The linear factorization for our given polynomial f of x is x minus the first root, which was the square root of 2, times x minus the second negative square root of 2, that's a double negative, x minus the minus I, and x minus the positive I. That's our complete factorization. All those factors are linear, first degree, because the x's inside are all to the first power. So you compare it to the f of x equals x minus a root times x minus a root times x minus... You can see what our roots are, and we can answer the second part of the question. Roots, also called zeros, are just the values that are being subtracted from x in each of the parentheses. So that gives us the list, the square root of 2, comma, minus the square root of 2, comma, negative I, positive I. We've got them all there. And we're finished.